Standard input and output. In this video, we are going to see about standard input and output. Unix is known for having many powerful features, which includes controlling the input and output. In Unix system, every program and Unix commands are connected to three files: the standard input, the standard output, and the standard error. Let us discuss about these files briefly. Standard input. The basic source from which Unix programs read their input is called the standard input. By default, the standard input is assigned to the special file representing the keyboard, that is the actual source of the input data. Standard output. The basic target to which Unix programs write their output is called the standard output. By default, the standard output is assigned to the special file representing the screen of your terminal, that is the usual target of the output. Standard error. The output target to which Unix programs write their error messages is called the standard error. By default, the standard error is also assigned to special file representing the screen of your terminal. Redirecting output of a file. In this video, we are going to see about redirecting output of a file. Although most of the time standard input, standard output, and standard error are acceptable to the user, you can also change them. You can change the input source or the output target. For instance, sometimes you may require getting input from the file instead of the keyboard, or you may want output on the printer instead of the monitor. In such circumstances, you need to redirect the standard input, standard output, or standard error. Redirection is a technique in Unix to reassign the standard input, standard output, or standard error to a specified file. Redirecting standard output. Let's look at the standard output. In the next command, the login ID fields from /etc/password are sorted by name. The output from this command is directed to a file called sortout. One word of caution here: when using sortout, or indeed any command that expects a file as input, make sure that the redirection operator is 2 spaces from the sort command. Otherwise, sort will think that it is an input file. Looking at our table, we could have used the following, which would have produced the same output. You can redirect output to an appended file from many commands. In the above, all grep's output, which list directories only, and output from an ls command matching file names that start with account, have been appended to the file files.out. To redirect standard output to a new file, use filename. Here, all the output from an ls command is directed to a file called ls.out. To append to an already created file or to create a new file if the file is not present, use filename. To create an empty zero-length file, use file name. Redirecting std out to a program, that is piping. In this video, we are going to see about redirecting std out to a program. In Unix, you can combine certain commands into one command by a technique called pipe or piping. Pipe is a mechanism that combines two adjacent programs or commands by connecting the standard output of one program or command to the standard input of the next program, that is, or command. So, the output of one command becomes the input of the next command. Piping is done by using the symbol I called a pipe symbol. The syntax of piping command is as follows. Examples. You can pipe the output of who command to the command v for counting the number of users logged onto your system by giving the following command. As wc1 counts the number of lines from the listing of who command, you will get the output in a number that is such as 4 or 5, indicating the number of users. To list the programs, that is example program 1 and program 2, give the following command. The cat command combines the two data files, program 1 and program 2, and n1 command reads from these files and adds line numbers. The more command displays the data screen by screen. Importance of pipes. Piping is one of the powerful features of Unix. Using pipes, you can perform a complex task by combining several simple commands. Pipes save your time and disk space. If you use pipes, there is no need to create temporary files that may occupy much of your disk space. For instance, if you do not use pipes to display listing of more than one program, that is illustrated in previous command, you will need to create temporary files as shown by the following commands. First, you will combine the two files, that is program 1 and program 2, and temporary file temp by giving following command. Then you will read the file temp, add the line numbers and store the output in second temporary file temp2 by giving the following command. Now you will read the file temp2 for displaying the data by the following command. Thus, two temporary files temp and temp2 will use your disk space unnecessarily, and you will require to delete these files by giving the following command. So piping not only makes your task easier but also saves the disk space. Combining output and errors. In this video, we are going to see about combining output and errors. The output and error messages of a command can be redirected in one command line. The syntax and function of combining the output and error redirection operators are as follows. Function: to make the command output and error messages go to the out file and error file respectively rather than the terminal screen. Note, both of two given commands function the same and the effect of them. For example, the output of this grep command is sent to the gfreshman file and its error messages are sent to the efreshman file. If gfreshman and efreshman don't exist, they are created, otherwise overwritten. Redirection to multiple targets, that is TEE. In this video, we are going to see about redirection to multiple targets, that is TEE. We can redirect std in, std out, and stderr together in a command or script or a combination of some of them. The following command redirects both std out and stder. Here, std out is redirected to log.text and error messages are redirected to log.text as well. In 2 and 1, 2 means redirect an error and 1 means redirect to std out. In our case, we have already redirected std out to the log.text file. So now both the std out and stderr outputs will be written into log.text and nothing will be printed on the terminal. To verify, we will check the content of log.text. The following example shows the std in, std out and stderr redirection. Here, the .bashrc file present in the home directory acts as an input to the cat command and its output is redirected to the out.text file. Any error encountered in between is redirected to the err.text file. The following bash script will explain std in, std out, stderr and their redirection. This script saves 2 snapshots of all running processes in the system and generates diff. The output after running the process will look somewhat as follows. Redirecting std in from a file. In this video, we are going to see about redirecting std in from a file. You can use the standard input to take or give input to commands. You will meet this in the AWK chapter. An example on giving the input to a command. The sort command is given its input using redirection, but I could also have used. Taking the above example a step further, if I wanted to produce an output file from the sort command, I simply stick an output redirection in telling the sort to send all output to a file called names.out. No output will go to the screen, that is apart from any errors. To mail a user from the command line, if message is in a file, just redirect the file into mail. Here, user Lucy gets sent mail with the message enclosed in a file called contents.txt. The redirection command delimiter is a useful command, more commonly called a here document. We will see this in action when we deal with here documents later on in the book. But for now, this is how it works. The shell takes all lines after the delimiter as input until it encounters the delimiter again, and the shell then knows to terminate the redirection. This command is very useful for doing automatic or remote routines. You can specify any delimiter. The word EOF is quite popular, but it's up to you. I like to use Mayday, but that's just me. You can pass variables into the here document as well. Here's an example. A file is created called myFile with a little text using the variables term and log name. Sending multiple lines to stdin. In this video, we are going to see about sending multiple lines to stdin. To connect the stdout of one command to the stdin of another, use the bar symbol commonly known as a pipe. Some examples. The first example runs ps to generate a list of processes and pipes it through the grep command to select lines that contain the word httpd. The output of grep is not redirected, so the matching lines come to the terminal window. The cut command in the second example picks out the path to each user's shell from /etc/password. The list of shells is then sent through sort u to produce a sorted list of unique values. To execute a second command only if its precursor completes successfully, you can separate the commands with an and symbol. For example, removes /temp/t2 if and only if it is successfully queued for printing. Here, the success of the lpr command is defined as its yielding an exit code of 0, so the use of a symbol that suggests logical AND for this purpose may be confusing if you are used to short-circuit evaluation in other programming languages. Don't think about it too much, just accept it as a shell idiom. Conversely, the double bar symbol executes the following command only if the preceding command fails, that is, produces a non-zero exit status. In a script, you can use a backslash to break a command onto multiple lines, helping to distinguish the error handling code from the rest of the command pipeline. For the converse effect, multiple commands combined onto one line, you can use a semicolon as a statement separator with even more clarity.